taking a look here, line segment AB, I'm going to go ahead and just highlight that in my pink. So from A to B, who can tell me what was that measurement from point A to point B? What was the measurement of that length? Richard? 3, okay, like 3, and it doesn't have like a feet or a inches, so when they don't have a measurement put, you just put units. So it's just 3 units, okay? What about from B to C? So I'll go ahead and highlight that one in blue. What was that one, Asia? 4, okay? So for line segment B to C, it's just 4 units. Okay, now how did you guys find that out? Like, how did you find out that it was 3 or 4? What did you do, Logan? Counted the boxes. Okay, that's a perfect method to say. So she just said she counted boxes. Everybody else did the same probably, right? Counted boxes. Okay. All right, now, could you use that same method to be able to find the segment for AC? Are you able to count boxes to find the measurement between A and C? No, why not? Because it's at an angle, right? It's not going directly straight across a box, like it's not going, side to side of a box or up and down from a box. It's actually cutting straight through the diagonal of a box. So no, you would not be able to use the same method in this situation. So when you have measurements that you're trying to identify and those points are at a diagonal, you can utilize your Pythagorean theorem to be able to solve. So right now I'm going to tell you that the measurement of AC is 5. Okay, the reason it's 5 is because this forms what we call a perfect Pythagorean theorem's triangle. It's a perfect triple. Okay, so where you have the lengths being 3 and 4, that means your diagonal is going to be a 5. But we can use a distance formula in order to be able to solve for our missing measurement or our distance between the 2 points that are set up diagonally. And the distance formula is the following. So D is going to be equal to the square root. So you want to draw a very long square root symbol. It's the square root of the sum of the differences squared. Okay? So what that means is that you're taking the differences between your x values. So remember we used to talk about x2 and x1s and y2s and y1s when we were doing slope. You're taking the difference of your x's. So it doesn't matter which point is x2 and which point is x1. It doesn't matter. You're just taking your 2 x values and subtracting them. And then you're going to square them. Jeremiah, you're going to get confused because you've been gone for the whole week. You're going to take the difference and then you're going to square that. Plus, you're going to do the same thing for your y's. You're going to take your y2 and you're going to subtract your y1 and square that value. Okay, so basically the idea is you take the differences, you square them, you add, you square root. Difference, squared, add, square root. That's the basic breakdown of what you are doing. And again, it does not matter the order that you pick your points to be x1 and y1 and x2 and y2. Okay, it doesn't matter which one's your first point, which one's your second point. And essentially what you're seeing here, guys, this x2 minus the x1, this essentially is going to be representing your legs. Like this would be A squared, and this would be B squared. Okay, those are essentially just representing the legs of the triangle that you could form that connects between those 2 points. Okay, so let's go ahead and identify that right now. The measurement or the point for A happens to be at 2, 3. And then C happens to be at 6, 6. Okay, so we have 2, 3, and we have 6, 6. And it does not matter, again, it does not matter at all which point you pick to be your x1, y1, x2, y2. It doesn't matter, okay? So for my x's, here's my x's. I'm going to highlight those in pink. So I'm going to subtract those. And then I'm going to highlight my y's in blue. And the lovely thing is, guys, that it doesn't matter if I do 2 minus 6 or 6 minus 2, and then if I do 3 minus 6 or 6 minus 3. Because even if I get a negative answer, once I square it, it becomes positive. So it doesn't matter the order that you subtract. So if you always want to do bigger number minus smaller number in this situation, you can. Okay, it's not the same thing as slope where order did matter. Here, order doesn't matter because you're eventually squaring it and it's going to get rid of the negative no matter what anyway. Okay, so if we take a look here, my x2 minus the x1, I'm just going to do 6 minus 2, and then I will square those. And then 3 minus 6, if I decide I'm going to keep it within the same order, and square that value. And of course, in between, I still have the addition sign, and I'm taking my square root. It doesn't matter. I'm keeping it in the same order because I did 6 minus the 2. Oops, sorry. Yeah, 6 minus 3. Sorry, my bad. 6 minus the 3. Okay? Keeping it in the same order, but again, it doesn't matter. I could do it in a different order. It's still going to come out to the same thing. I could still do 3 minus 6. It'll still come out to the same thing. Okay? 6 minus 2 is going to come out to 4. So we're going to have 4 squared. 6 minus 3 is going to come out to 3. So we're going to have 3 squared. Okay, what is 4 squared going to equal? 16. What is 3 squared going to equal? 9. I'm coming down. Okay. So like I said before, you're going to take the difference, which is what we did. You're going to square. Now we're going to add. What do we get when we add that together? 25. And then we're going to take the square root. What's the square root of 25? 5. And remember, we're always going to choose the positive root. We're always going to choose the positive root because it is geometry. So the distance for point A to point C is going to be 5. Okay? Now, it's important to understand the formula because right now I could easily just make a triangle and then do Pythagorean theorem and make it easier for me. But sometimes they're not going to give you the actual coordinate grid. They're just going to give you the 2 points, and then you have to figure out the distance from there, and you won't have graph paper to utilize for that. So you want to make sure you understand the formula. Again, you're subtracting your x's, then you're going to subtract your y's. You're then going to square those values. You're then going to add those values together, and then you're going to take your square root. Difference, squared, sum, square root. Okay, so if you want to write that little note off to the side, you can. You're going to do the difference. You're going to square. You're going to take the sum, and then you're going to square root. That's the 4 processes that you're going to be doing. You could type the entire thing into your calculator all in one swoop too if you want. Perfectly fine. Just make sure you don't mess it up. All right. Go ahead and flip it on over to the back. That's the best handwriting you've ever had. So proud of you. Okay, we'll do one more together. Okay, again, it does not matter the order that you subtract, but here's my x's. I've got a 1, and a 7. My y's are a 9 and a 1. So when I'm setting this up, I'm going to do the square root of the difference between my x's. So I'm just going to do 1 minus the 7 squared plus, I now need to do the difference between my y's. So I'm going to do 9 minus 1 squared. Okay, what's 1 minus 7?
9.
Negative 6. Strong and wrong, Lucas. Okay, so we're going to have negative 6 squared. Here, let me zoom in so you guys can see it a little bit better in the back. So we'll have negative 6 squared plus, what's 9 minus 1? 8.
8.
Okay, so we're going to do 8 squared. Okay, so negative 6 times negative 6 is what? 36. So we're going to have 36. 8 times 8 is 64. Okay, so now we have the square root of 36 plus 64. What's 36 plus 64? 100. Okay, so we now have the square root of 100. And what's the square root of 100? 10. So the distance is going to be equal to 10. All right, go ahead and try the rest of those on your own, please. All right, let's go ahead and go over it. For problem number 2, you should have gotten 13. Okay, you would have subtracted your x's, negative 2 minus negative 7, which gives you 5, and you'd square it, gives you 25. Subtract your y's, Asia. Subtract your y's, you'd have negative 7 minus 5, that gives you negative 12. You'd then square negative 12 and get 144. Be mindful because, so I'm going to use Jeffrey as an example. Jeffrey said, hey, I thought you said that a negative squared will always equal a positive, but when I typed it in, it gave me a negative. If you don't put your negatives inside of a parentheses before you square it, then yeah, it's going to come out as a negative inside of here. The reason being is because your calculator, when you're typing negative 12 and then you're squaring that, that squared is only going to the 12 and not to the negative. So obviously it's going to give you a negative answer because it's just saying, oh, it's the negative of 12 squared. Whereas here, if I put the parentheses around the negative 12 first, and then I square it, then it's going, oh, I'm taking negative 12 and squaring that value, and that gives you your positive. Just think logically. You know a negative times a negative is a positive, okay? When you added the two values together, you get 169. Take the square root, you get 13. For problem number 3, you should have gotten 4.6 if you rounded correctly. You would do 1.5 minus a negative 1.5. Sorry, I had to squeeze my negative in there. So 1.5 minus negative 1.5 gives you a positive 3, and then 3 squared gives you 9. Then we do the same thing for the y's. We're going to do 2 minus the negative 1.5. That gives you positive 3.5. When you square that, it comes out to 12.25. Then you add those values together to get 21.25. Take the square root of that, and you get 4.6. Okay, for problem number 4, you should have gotten 8.2. If you do 5 minus negative 3, you get positive 8. Square it, you get 64. For the y's, you do negative 4 minus negative 2. That comes out to negative 2. Square that, you get positive 4. Add those together, you get 68. Take the square root, 8.2. For problem number 5, you should have gotten 7.6. You do negative 3 minus the negative 6. That comes out to a positive 3. Square that, you get positive 9. Then for the y's, negative 2 minus the negative 2 minus the 5. That comes out to negative 7. Square the negative 7, you get 49. Add those together, 49 and 9 together give you 58, and square root it, it's 7.6. For problem number 6, you're going to subtract the x's. 1 minus the 3 comes out to a negative 2. Square that, you get positive 4. Subtract your y's, you're going to have 5 minus 1, which is going to come out to 4. 4 squared is 16. Add the 4 and the 16 together, you get 20. Square root it, 4.5. Okay, for problem number 7, Subtract your x's. 2.5 minus the 0.5 comes out to 2. Square that, you get 4. Subtract your y's. 3.5 minus 4 comes out to negative 0.5. You square it, you get 0.25. Then add those together, you're going to get 4.25. Take the square root, you get 2.1. Okay, and then for your last problem, subtract your x's. You have 8 minus 4 comes out to 4. 4 squared comes out to 16. Then subtract negative 4 and negative 8. You're going to get positive 4. 4 squared is 16. Add those together. You're going to get 32. Take the square root. You get 5.7. Loaded into Google Classroom is your assignment. You have 2 IXL skills. Go ahead and get in.